Hello everybody. So I guess I'm back right now with a new stream. It's actually very cool because well, I was thinking, what can I do on a Friday evening? Well, it should be a little bit relaxing. But then first I thought about playing some chess, or I don't know, playing some video games. It's a long time since I didn't fire up my Xbox. But then I thought maybe I can do something that for me would be just a little bit relaxing, but that could also be very important for others, like that they could benefit. And then I thought, okay, let's try a new stream. And this time I will try to build basically a web API, an Eshop API from scratch, I would say. And it's targeted towards a more junior audience or beginner audience. So if it happens that you are a beginner developer, or you just want to, well, sedimentate your knowledge about how to build an API in ASP.NET Core, I think that this stream will be very useful for you. I won't do some very fancy stuff here, just basic API things that we do in ASP.NET Core, so that we can get a little bit accustomed with the model view controller architecture and everything that an API in ASP.NET Core needs. And I thought about taking an Eshop as example because that's an experience that we are also, all of us mostly, very familiar with it. And that's why I thought it would be easier to get it going. If you happen to be right here, then I would be more than happy if you could engage in the chat. It's really very important for me to see some feedback, because streaming is very interesting, but I really want that my streams would also be useful for at least one or two persons. So I'm really not targeting really a huge audience of thousands of people, but I really hope that at least for some of you, or at least for some persons, these streams would be useful. And I guess right now you are able to see my Visual Studio. It's basically blank. I have started it without any code, because what I plan to do is to start it here together with you. Also, if you have questions at any time, also please feel free to write in the chat. Please don't be afraid that there are stupid questions. I always say that there aren't any stupid questions. So I'm really open to hear all your concerns, and maybe we can work your questions out so that in the end you would learn something from this stream. I guess that's the most important thing right now. So let's get started. I just want to check the audio first. Just 1 second. It seems that it's fairly okay, I guess. So yeah, we can go ahead. Okay, so we plan to start a brand new project right now, a brand new solution. And the way I usually like to do this, if we go here to Visual Studio and then File and New and then Project here, but the cool thing, or usually when I start new projects, I just like to start off with a blank solution. But yeah, the blank solution. This is what I want to have, because I want to manage my project there, to create my projects. As we'll see, I guess we'll create a bunch of projects, so it won't be only one project. So let's click next, and I will name this Twitch Eshop, so that I know that this is for this stream. And right now the solution is created. Okay. So the next steps, of course, we will need to add some projects. And whenever we start basically working on something new from scratch, we have to think just a little bit about how do we want to organize our folder structure, our projects, our source code files or classes, and so on. Normally in most tutorials for beginners, when you talk about APIs, they just create a new API solution or a new ASP.NET Core API project, and everything goes basically there. But since I assume that those of you who are watching right now are already a little bit familiar with what .NET is all about, C#, Visual Studio, and so on. And you might also have probably some very, very basic knowledge about application architecture. I really like to keep it clean, even if it's for demo purposes, even if this won't be a project that will be placed in production somewhere, but I just want to keep a pattern, to try to write a clean code and a good code. And it starts really with how do you architect your projects. And of course, the first thing that we would have to think about is about how do we model the domain. So what classes do we need for an eShop? And this is the place where we'll start to add a new project to this existing solution. And for this one, it will be focused on the domain model. And in this case, I will go for a class library because we don't need a console application or an ASP.NET Core application. We just need for this a really blank class library. So let's do it, and I will name this Twitch. I will from here we select the library and then next. And on this screen let's Twitch Eshop domain. So this is the way we know that our project is for the domain. So right now it's creating it, and I guess you will see it just in a short time. Okay, so yeah, this is right now a blank new project that will contain our domain. It is a class library. It has here this class 1, but I guess I'll delete it because we won't need that class at all. So let's delete it. We'll create the classes that we need and the folder structure and so on. But besides besides the domain, one other thing that we will need, at least for now, is let's click on add new project, and this would be the project for our API. So if I start here ASP.NET Core, let's find the solution. Let's take ASP.NET Core Web Application. Here I would call it Twitch Eshop.api because it's the API part, and this will be basically our front end, our API, where we have our controllers and everything. And here when we click create, but I guess right now you are not able to see my other window, so just give me 1 second. Okay, now you should see also the window that I have here. So what we get here is basically to choose what type of project do we want to build, and there are some pre-configured templates that come with ASP.NET Core or with Visual Studio, I would say. I also have some projects, some project templates that come from preview products that I already have here. But what we actually need is here we see that we have an API. And the easiest way to get it going with an API, we just click on this type of project, then create, and then a new window will open where we will have to, oh no, it didn't open, it just created the project. So let me close this window. So right now we see that this is a really basic project. It's already pre-configured with a weather forecast. It's the standard template that you have in ASP.NET Core. We'll be most probably deleting most of what's here by default, like this weather forecast controller and the weather forecast. Basically, the only things that we need here is the startup class, and we'll come to the startup class just in a few seconds. And then we have this program.cs, which is basically the entry point in this API application. But for now, as I said, what I want to do is not concentrate on the API, because first of all, we need to model our domain, because our API should display some data. So when we make requests to that API, it should return some data, and that data is basically is our domain model or our classes and the entire logic that we have behind it. So I'll just go to Twitch Eshop domain back, And if you ask yourself, what about the databases? Well, we don't bother about the database right now. At first, I guess we will have something like a seeder that will hard code some products, some suppliers, some shopping carts, whatever we need directly in memory. And then at a later point, we'll probably also add a data access layer with Entity Framework Core. But for that, we will create at that time a new project. Right now, I think that this setup that we have here is okay to go. So we have this domain, and that should be fine. Okay, let's then start. So in our domain, what do we need in our domain? Let's just think a little bit about this eShop. So we probably will have to deal with products. So we'll probably need a class that is called product. So let me create a folder in this project and right click, add folder, and let's name it models. And in this folder, I guess we'll place all our models. Okay, and on this model, in this folder, let's add a new class. But I guess you still are not able to see all the things that I see. So let me just switch back to this one. Sorry, it's still getting started with streaming for me. So yeah, we'll add a new class, and let's start by adding a product. And add. Okay. Let's make it public, I guess, for now. Good. Then, of course, the next question is what do we need on a product? Of course, I won't expect that we will see or that we will add really all the properties that we need right now, because it's not possible to know, at least for me in this exact scenario, it's not possible to know exactly what do we want to display as a product, or what properties a product has. But what we can do is simply get started and see, once we go further, when we realize that we need maybe something else, then we can simply come here and add everything that we need. And this is also the place where you come in, because if you have any suggestions of functionality that we might need to add, about things that we might do differently, or if you have questions, just please write me in the chat, and then we'll be able to communicate. By the way, let's say hello to everybody that is watching right now, and let's start with the product. So what would our product most probably have? Well, it will probably have an ID. So let's create a new property. It will be of type int. Let's call it ID. And then the getters and the setters. And what other things would the product have? Well, it would probably have a name, and it will be of type string. It would probably also have description, I guess. So, and this would be also of type string. So public string description. Okay. What else would a product have? It would most probably have a price. Let's make it double. Public double price get set. Okay, what could a product also have? I mean, most shops or most products that you see in shops, they have usually a supplier. So it's basically the entity that is delivering the product, or that creates that specific product. So yeah, we will need a supplier in this case. But a supplier is once again a very, I would say, a more complex entity. So it's maybe not okay to just have it as have it as a string here. So this is why I guess the best way right now it would be to create another class. So let's then add class. and this class would be supplier. Let's make it public. Class supplier. What properties would this supplier have for now? It will also have an ID that would be of type integer. It would public string name. It's the name of the supplier. It's I don't know. Let's also have a public string description, because in most cases there is also a brief description of the supplier, what the supplier does. Maybe we want a website URL. Each supplier would have a website URL, and for now we'll I said we won't do any fancy stuff, so we let this URL of type string, but we'll call the property website, and that's basically it for now. Because here we could use for instance path strings or similar things to make sure that we have always a valid URL. But right now let's maybe not focus directly on this type of things. Okay, so in this case we can go back to product, and we have public. It would be supplier. The property would be named exactly the same. Get set, and yeah, that should do it. Now, what else can we have on a product? Even if this is an API, we can maybe in the responses that we return, we can also return a URL that contains a location from where clients then can download the image of the specific product. So when we build a front-end client for that one, either in Angular, React, or a normal MVC application. So let's also add this in. Let's add it also as a string, and I will say here, I will say this would be called photo URL and get set. Sorry. So any ideas on new things that a supplier might have? Let me just check here in the chat. No, nothing here right now. So let's continue in this case. I think that right now we have here a basic product. What our eShop would most probably also have is a shopping cart, because well, of course we need also to buy the things there. So let's create a shopping cart. Add class. This would be a shopping cart. Let's make also this class public for now. That would have also a public int ID. Now the shopping cart itself, it doesn't really need a title and a description. It's basically an ID and a list of products basically. So in this case, what I suggest, we won't have any properties like title and descriptions. But what we need, because each shopping cart in a certain way or another belongs to a certain customer or a certain user. So even if we can create shopping carts if we are not logged into an application, this doesn't mean that that shopping cart doesn't have a user associated with it. It could be that the user is an anonymous user instance, but it's still most probably will need to have a customer associated with it. So in this case, let's add a new class, because we have to define a customer and make it also public. Okay, so what we have on a customer, it would be public int ID, because each customer will probably also have an ID. It will be persisted in the database. The customer would probably also have a name, and let's assume that customers are normal or regular users, not other companies. And regular users usually also have a name, and I could say here string name and get set. Now the big problem here is with name is that the whole idea of a name is not a simple string. It basically has different components, like a first name, like a last name, like initials, and so on. So what I guess it would be good to do right now is to create a new class that would be a name, and then in that class we will define what a name in our application basically means. This is the whole idea of having classes. So let's have a class that is called name. Now this name as it is, I don't think that we will persist maybe in the database in this format, or even though maybe, yeah, let's for now, for simplicity's sake, create a name that also has an ID, public int ID. If you want to get some more advanced stuffs, on Wednesday I'm streaming another episode of creating a social network from scratch, where we also start coding, but in that case we follow the domain-driven design principles and patterns, and the entire solution is really way more complicated than what we're building right now. So if you want to learn more about different type of objects or domain objects that we work with, and how we persist them in the database, and everything that we need to think about it when we create our domain models, then please feel free to join me on Wednesday. It will be also a stream that I will do in the evening, and then we'll really discuss a lot more about different types of domain models. But right now I guess it's okay to have this to have each name also an ID. Now, of course, for the name, we would then have a public string, and it would be a first name, and it would also have a public string, it would be a last name. And what we could have here is also maybe public string initials. Gets it. Though I guess that here, if we can do some more fancy stuff right now, is that we could simply calculate the initials based on what we have in first name. So but right now let's leave it like that. I said I just want to keep it as simple as possible for now. Then later maybe we'll go and do some more complex stuff. What I plan to do right now is simply outline the basic domain layout, or the domain models that we need, and then further we'll see how we can enhance them afterward. So we left here at customer. Now we have a name class, so each customer would have a name, which is okay. Okay, of course we then have to delete this property of type string. I didn't notice that I have created it. Okay, then what we also have usually when it comes to customers is something like the social security number, and that would be a number. Let's make it long because it's usually a long one, and it won't be, oh sorry, I have to give also a name. Let's name it SSN from social security number. We'll also think about just later if probably this property shouldn't have a public setter. We should be able to set this social security number only after we validate it, and within this customer class, keeping or making sure that that this customer object or any customer object that is instantiated from this class is always in a consistent state when it comes to that social security number. Okay, what a customer would also have is contact details, because we have also to contact the customer, and well, there we should know how to contact the customer. So for that we would need another class. Let's create it. It would be contact details. And what do we have in this class? We have in this class because also each contact detail will be persisted in the database. It will also have an ID, public int ID. What will we have right now, or what we will still have is public. Let's make it string to be easier. Phone number. Even though if I think better about phone numbers, I guess that could be also a separate class, because a phone number is I would say also a kind of more complex object that would have a country code, that would have an area code, that would have the number itself. And if we would do this for real, then I would most probably create a different class for phone number. But once again, for simplicity's sake, right now let's just have this phone number as a string. And what we will still have here is a public also string email address. Of course, we could also do some validation on these properties at a certain point to make sure that they are really phone numbers or that they are really email addresses. But that's something that I think we'll have to think about just a little bit later. But one thing that I wanted to point out is that contact details itself, they wouldn't actually make sense as standalone information. So they would make sense only if they are in a certain way bound to the specific customer that we want to contact. So in this case, we can also think about describing this in our model. And I will say here, I will add another property. This will also help us when we go further and we implement Entity Framework Core. And here I would have the public int and the customer, but the U shouldn't be capitalized, customer ID. Okay, and this contact details, I think it's okay for now. So let's go back to customer, and here for customer we have here this contact details. Although a customer can have several different contact details, so in this case we can simply, well, say that it's an I collection. We want to have it as a collection. I collection of contact details. Although I'm not happy with the naming of this class, so I will rename it to contact detail. And I will say yes, because I want to make all the changes everywhere. So it's a I collection of contact detail, and it would be contact details. So this would be then pluralized, because this would basically contain a list of contact details. So each customer, when he registers for this application, he will have to provide some at least one pair of or at least one contact detail entry, because otherwise we couldn't have him as a customer. And of course, customers also would like most probably will also have a username. And yeah, that's pretty much it for now for the customer. I'm not sure exactly from where we left. It's not really easy to talk that much, so I have to drink a lot. Good. Let's go one step further right now. And what I'll want to do is okay, let's check. It was the customer. I guess it's ready. I think we started from product, but the product is for now done. We have the shopping cart, and in the shopping cart, yeah, here is where we started to build our customer. So each shopping cart should have a customer property. That's it. Okay, what other type of information do we usually have in shopping carts? Each shopping cart would have a total price. So let's make a double. For now, let's have it with getter and setter. Although I think that fairly soon we have to implement here one thing which is called probably shopping cart product. So the product that is placed in a certain shopping cart, and probably the total price should be calculated based on all the products that we currently have in the shopping cart. But how do we basically define a shopping cart product? It's basically a product that belongs to a certain shopping cart ID. So it's really not a big deal for now. It will get a little bit more complicated when we go to entity framework, but I think for now we can simply have here public list of product shopping cart products. But no, we can simply name it product, because if we are in the shopping cart context or shopping cart instance, when we say product, it's clear that we mean the products that are currently there inside the shopping cart. So that shouldn't be any problem. So right now, what do we have? Let's make a short summary. So we have customer, and we'll probably have on the API a customer's controller. So a controller through which we can get information about a certain customer. What we also have, we'll have a products controller probably, and through that controller we'll be able to get information about the products that we currently have in our eShop. And then we'll have the shopping cart, and we'll probably have also a controller which will be probably called shopping cart controller, that will contain all the information that we have in a certain shopping cart. So I guess that that would cover it for now. If you have any other ideas, then please just let me know. You can just write me in the chat. Okay, second. Good. So in this case, we can right now try to go just a small step forward, and to think about, okay, how we can get this information to be displayed in an API. So right now we have the very basic domain models, and I guess we can simply go further. So in this case, we'll continue with the Twitch eShop API, because we can already start working on that. And what I want to do before all, I just want to really get rid of all the things that we don't need here. So first is this weather forecast class. We don't need it. Go away. We don't need you. And we have these controllers, which is the weather forecast controller. And okay, it's also here that well, we don't need this weather forecast controller. We'll create our own controller. So yeah, let's click on delete here, because we'll create our own controller. Okay, the startup class, which is a very important class in ASP.NET Core. If you're not 100% familiar, I just will go through it once again. The startup class is basically where we configure our web application, I would say. Sorry. And what this means is that, okay, we have, of course, a constructor, and in this constructor we will always receive an iConfiguration object. The configuration object is very important because it allows us to configure our web application. And the configurations that we do here in the startup class are basically two, which are very, very important. It's first this configure services method, where we add the services that we need to our web application. In this case, it's an API, but here is where we add the services, and then we have this configure method where we can configure the middleware pipeline. And if you're not 100% familiar with middleware, if you check my YouTube channel, if you scroll down on my Twitch channel, you will see some links to all my social networks, and then there is also a link to my YouTube channel where you can check out. There are 2 videos on middleware in ASP.NET Core. There is a part 1 which basically takes it from scratch from right here where we are right now. But then in the part 2 it gets into more complex scenarios where we can create our own middleware. But right now for this application, for this API that we'll build, I guess we don't need, or we won't need, any custom middleware. But just go to YouTube and watch these videos if you're not 100% familiar with what middleware is. But it's basically the pipeline through which each request will flow when it comes towards our application. And of course, each response will travel the same pipeline but in reverse order when it leaves our application. So what this very basically means is that when a request comes in, we can imagine that it comes from up, so it comes from here, and then it means that it will go through the entire pipeline. What does this mean? It will go through each middleware, so each of these methods that you see here. First of all, if the environment is a development environment, it will add, or it will go through this middleware. Then it will go it will go to the next one, to this here. Then it will go to the next one, which use routing. Then it will go to the next one, which is use authorization, and so on. So basically, and the response, when a response is generated, it travels the same pipeline but the other way around. So it will go to use authorization, use routing, use HTTP redirection, and so on. The cool thing about this whole idea of middleware pipeline is that we can actually, at each step or in each middleware, we can add a lot of different logic that we want to perform or on a certain request. For instance, if we want in our API to build a I don't know, like an Google Analytics style of service. So we want to know exactly how many requests did we have, from which regions, and so on. We could simply build our own analytics middleware. We can add it. We can add that middleware to this pipeline, and then each request would go to that middleware. And in that middleware, we can perform our logic. So we can look up, okay, from which IP this request comes from. Then we can maybe look up an external service and resolve that IP to a certain area, like a country or region. Further, we can see that, okay, we have a request we have in a database, you know, somewhere where we save the number of requests. We just increase the number and save the new number to the database, and so on. So this is basically the whole idea of a middleware. It can be used also to accommodate some more complex scenarios. For instance, you could do exception handling or error handling in a middleware, so that you don't have to scatter your exceptions everywhere in the application, or at least the errors that you want to return to the user if something went wrong. You can simply add a middleware, and based on the response that the application generated, you can then present to the requester a custom return type, maybe with an error code and a description of the error that occurred, instead that the entire web application would break down. So yeah, this is really powerful. It's you can really add a lot of things, a lot of logic here. The only very important thing to remember right now is that each request and each response basically travels through this pipeline of different pieces of software, of different middleware, how they are called, and there you can perform your logic, or you can perform really anything that you wish to do right there. Right now we don't have to add anything else to this middleware pipeline. These are the standard middleware that are added by ASP.NET Core when we created a new project. So yeah, that's basically the whole idea of middleware. Then the program.cs class, this is the starting point of the application, or the entry point of the application. So when we run the application, what it happens is that it will start here, because in the end, maybe you didn't think about it this way, But an ASP.NET Core application, or an API in this case, which is still ASP.NET Core, is nothing else than a console application. And this is why we see that we have this class program and we have this public static void main method that is the entry point in our web application. And in this entry point, we simply call this create host builder, which creates our web application. And here we see that it creates a default host builder. And when we see, okay, we want to configure this host or this web application, and we say use startup. So this means for the configuration of this application, use the startup class, which is exactly this class that we have here, which means that when ASP.NET Core is doing these steps, it will simply add all the services that we add in configure services, and it will add all the middleware that we have added here. It will add them to our web application. And I also just want to show you one thing. So if we go here on I want to run the API, so let's run it using IS Express. So right now, when we start the application, of course it will build it, and I hope that there isn't any problem, so that I don't have any errors. No, but it opened it on the other screen. So it opened basically here a web browser, and this web browser tries to do a request to weather forecast, of course. And since we deleted the weather forecast controller, of course that it doesn't find it, so it can't really respond. So at the end, we'll probably receive in the browser a response type of something like a 404 not found or similar. But what I like to do always when I'm working with APIs, because I think it's really not optimal that every time I want to debug the application and I start it, it's really not optimal that it opens a web browser. For APIs, I don't really need them because it's just some endpoints there that I have to call, however, with different tools, so not with the web browser. So it's really not helpful at all. And what I want to do is I go usually to the project, and if we click on properties, here you see that well, we have this this type of application, which is API, and we see that the output is a console application. So this is okay, but what I want to do is that I really don't want to. So if I go to where is it, to debug, what I want I don't want to start it in IS Express. But I want it to start as a console. So instead of having IS Express, I just took this Twitch Eshop API, which is basically the console for this. And then I also don't want to launch it in the browser. Then if I click on Save All, in this case, I guess it should open my application in the console, but I have also to change here to not be IS Express. And in this case, right now, when you see right now it opened the console window, it didn't open a browser. And for APIs, I think this is really the best thing to do because you don't really need a browser. And in this case, that's what happened right now. But there's still something that I'm not 100% sure why it's not opening. Okay, sorry, it's a little bit different. And here we see that we have the URLs on which our web server is working. So right now, if we go, for instance, to Postman, and we can use Postman to check our APIs. I usually always use this tool. And if I get, if I do a GET request to this URL, it should I should receive 404 not found. Okay, it didn't find localhost 5001, which is a little bit strange. Yeah, because okay, of course, because we don't have right now any controllers, so the application doesn't know what to respond. However, what I wanted to show you is how you can basically make your web API start in the console and not in the browser, because it's really not useful at all for APIs that they will start in the browser. And if you didn't know this trick, I hope that that's okay for you. So I see, yeah, we had here right now a number of viewers. Hello to everybody. Let's also write in the chat, and please also, anytime you have questions, if I talk about a topic that maybe you want to get some more information, then just please let me know in the chat. I really would like to make this well, as dynamic as possible, because my primary focus with these streams is really to help people that maybe have questions regarding .NET generally. So if you have any questions, please feel free once again to drop the questions in the chat, or if you simply want to add something, or if you want to ask for, I don't know, for a certain type of information or advice, whatever, just please feel free to engage me. I would really highly appreciate that. Okay, now let's go one step further and see what we'll try to do next. So what I plan to do next is to create a controller. Let's start with the products. So if we right click the controllers folder, then we will add a new class, and in this would be a class called products controller. Okay, and controller, in the default template, ASP.NET Core inherits from base controller. But what I like to do is just to inherit from the entire controller, because in this case, I can have all the powers, or I can use all the features that controllers in ASP.NET Core have. So for this, we will have to import this namespace, of course. And if you ask yourself, how do you make a class being a controller? It's exactly like that. So it's simply like that. You just make this class inherit from controller, and that's how you make a class become a controller itself. So right now, if we think just a little bit further, just 1 second. The next thing that we would have to define on the controller is the route. And here we can simply use an attribute. That's usually the way how we do this in APIs. And then here we say that, okay, I want this controller to respond when when a request will come in for the host name, then /API, and then /, and I can simply put a placeholder here for the controller. So this is the way I have defined this controller right now. What I can do here is create a constructor for it. Okay, something went wrong. Okay, so I have created a constructor for it right now. In this moment, so in this very, very specific moment, we don't really need anything in this constructor, but this is usually the place where you do a lot of dependency injection. You inject all the services that you need in a certain controller to fulfill a request. You simply have to inject them in controllers, and then you can use them from there. And we'll also come to services just a little bit later. Now let's try to test our controller out. For this one, we need a controller action. So a controller action is nothing else than a C# method that well, belongs to a controller, and that is responsible to return a response result. And usually the way we do this in .NET Core or in ASP.NET Core, this type of methods return iAction result. iAction result, and let's see, get product, or let's have it get all products, whatever the name of the method is really not important right now. One thing that you can do here is simply specify to which HTTP verb it should respond. So I say that this method should be triggered when we have a GET request. So if a GET request comes here to API, to this URL, to this endpoint /API/controller, then it will trigger this action. And action result is what controller actions return in ASP.NET Core. Now, in case of APIs, usually the action results, it's always an OK and then an object that will be eventually serialized to JSON, and it will be presented as a JSON response to the client that requested or that made the request to that URL. But iAction result, or why I actually use iAction result and not very specific result like a JSON result or any other type of results, is that when I return an iAction result in a method, depending on what happens in that controller or in that controller action, if I don't know, maybe I encounter some errors or some very specific things happen there that put my application in or the state of the request in a non-consistent state, or if anything happens, or depending on the logic that I have there, I might sometimes maybe return a normal JSON result, but sometimes maybe I don't return a normal JSON result. Maybe I want to return a redirect. For instance, I don't know, if there is a request to get a photo, then I maybe want to return a redirect to the specific location from where the client can download the photo. So I will usually use this action result of I would usually use this iAction result as return type in controller actions. And of course, if you work with database connections or anything that is remote or that it requires asynchronicity, you can simply always return a task of iAction result. It could be like this. Right now, I think we won't go into this async and await, because I just want to have a very basic API started. But we'll probably develop it further in other live streams to also include a little bit more complex stuff. But right now, I just want to get us started with this API and understand the basic logic of it. And here, just just to have a test, let's create here maybe. Let's create a new product. New product. Okay, it doesn't know about the product because we haven't add a reference to the domain project. But if we look here, it no, I don't want to do. But it's not product, sorry, it's product, and it should give me a hint that I would need to add a reference to Twitch Eshop domain, which is exactly the thing that I need. So in this case, the domain project was added as a reference. What does this mean? It does mean that if we go here on dependencies and when we have projects, we see that we have this Twitch Eshop domain. Previously, it was not there, but when we clicked to add it as a reference, it just referenced that domain project in my API project so that I can use all the classes inside that domain project. And now I can create a new product. Let's see. Okay, what do we have here on product? Let's set the ID. So right now, let's make it 1. I don't know, but it's name, and the name should be okay. Let's no, the product name should be a simple name. Let's have it, I don't know, IP camera, and let's have a price. Okay. Sorry. Okay. So right now, this F basically we used to make this this a double, because price it needs to be double as a double data type. So we need to add this F at the end that would indicate that this is a double. This is not a different data type. It is a double, and that would be the price right now. So what we can do here is simply say right now return okay. And we put the product in there, and right now I think it should be fine. And I guess that this is also the point where we can test this out actually. So let's run it again. So my console application started. It just takes a while because there are a lot of software running on this computer right now for the stream. So yeah, we have this API running, and if we go back to Postman, we have to slightly adjust here the endpoint, because we said we want our this controller or this controller action should be triggered when we make a request to hostname /API/products, and then here we can have yeah, I think that's basically it. The request is also set on get, and we see that we have received a response. Of course, the values that we set, they are there, but for all the properties for which we haven't set any value, we simply have null. So basically, this is the first test, and it confirms that our controller is working. You see, it's really not very complicated, the entire idea of how controllers in APIs should work. And what we can do further is let's make another method, and let's make it public. I action result. This would be get product by ID. And here I guess it would be, I would have to say it was int ID. Okay. And here I would have to also specify this is just a little bit more complicated. It would be also available on HTTP GET. But I would like to also define a route here, because according to the REST principles, the route here should be just a little bit different, because usually in the URL, so in the endpoint, basically we should have the ID that we need to identify that certain product. So for instance, we could say here that we want to have a parameter which is called ID, and you notice that we put it in curly braces, and as long as that name that we put in curly braces is exactly the same that we have put here as an input parameter, basically it will take the value from the endpoint, from the URL, and it will pass it in here to this controller action. And this is actually helpful, because when we will have the database, this is the way that we get the ID, and based on that ID, we simply go to the database, search for that specific product with that specific ID, and then we return it. Right now we don't have any database, and I just want to get it working in a very basic way. So what I will do is here I will copy this part of code. So usually it's a very bad thing to copy and paste code, and I usually don't do this, but for demo purposes right now, because I just want to see that this is working. And here I could maybe, instead of hard coding the ID, I want to put it to the value of the ID that we have it in the URL. So then we have return product. So let's test this out. Just a few seconds so that it will start. So what it still starts. Let me see. So right now we have this /API/products. This should return the exact same product that we had previously. But then if we add here, for instance, /5, which would be the ID, in that case it returns a product that has the ID 5. And if we let me just go back here and put a breakpoint right where we enter this controller action, and then let's make the request once again. And of course we hit that breakpoint, and what we see here is that, as said, we have as input parameter number 5, because it was 5 that we have put here in the URL. So with this curly braces and ID, we have defined a placeholder for the ID, and it would ASP.NET Core would take it from the URL and pass it in as input to our controller action, and from there we can simply use it. So if we click right now on continue, it will of course return the response, and the ID will be 5. But for instance, if I change here the ID, in this case it will be 100, we'll see that it will once again hit the breakpoint, and in this case this ID will be 100, and as a result, subsequently, in the response that I will receive, also the ID is set to 100. So this is also how you can basically get information from the endpoint as an input in your controller action, and this is how this is supposed to work. Now, right now, there is another very interesting thing. Of course, we want to go just a little step further and maybe not hard code products here in the controller. But what I would like to do right at the beginning at the application, so just about now, is to work with something that we usually call a seeder. Now, the seeder is a class that you'd normally use to pre-populate a database with some information if that database is empty. But in our case, we can also use a seeder to simply populate some in-memory collections so that we can use them throughout the lifetime of the application. So as long as this web application is up and running, then those collections would be there. And in that case, we could already, let's say, kind of simulate the idea of a database behind. So I would say that as a next step here, the best thing to do would be to create a service that would simply populate right now a list of products. But I think that before we go further, I would like to take a short break. So we'll go on a 5 minutes break right now. And when we get back, we will create this seeder, and it will be a service, and that would be really a very, very good point to also talk about services in ASP.NET Core, or services that we add here, because there are different type of lifetimes of services. And we'll also take a look about, okay, what's different, for instance, if we have a singleton service, or if we have a scoped service, or if we have a transient service. And I think that that would be some very cool stuff for you to see and maybe understand better if you don't till now. Okay, so I will be right back in 5 minutes. I promise you it won't take longer. I hope you won't go away, and we'll hear each other then in 5 minutes. Okay, I think we are back right now, but I'm not sure if you can see the camera. Probably not. Let me try to fix this. Okay, it seems that that my camera doesn't want to work anymore. I'm not sure exactly why this happens, but let's try again. Okay, I think now you can see the camera, but it's sorry, just one more second, and I think I will be. Re-adding this. Oh yeah, right now you should, yeah, we should have the camera back. Just a little bit bigger, put it in the corner, and yeah, that should be it right now. Okay, so let's continue. I guess the best thing to do right now is to, as said, go ahead and try to create a seeder. Once again, why we want to do or to create a seeder is because we simply want to add some fake data each time that we start up our API. We want to have some data in there so that we can really display some products, and that we can really well create and get products by ID and so on, or create products or delete products or update products, and everything that should be done via an API. So let's get started with the seeder. For this, we'll create in this API project again. So we're still in this API project. We create a new folder which would be called, first of all, services. And let's, where is it? Here, add, I would then like to add a folder which is called services. And in this folder, I would add a seeder service. But the way we usually work with services, in order to be compliant with the whole principle of dependency injection or dependency inversion in according to the solid principles, we always have to expose the services throughout an interface. So that's why we need an interface that would define some methods specific for this seeder service. So we'll create a new folder here that we will call interfaces, and in this folder we'll create a new interface. So let's add a new class, it was called, and from here we will there should be interface here, and as a convention, you might know, we should name it iSeeder service. So my service would be seeder, so iSeeder service. So, or iSeeder, let's not make it too long. And then okay, add. And in this interface right now, what we need to define is basically, oh sorry, not there, here. We need a method that would return product or a list of product. Sorry, not that way. List of product. A list is basically an I collection, and this would be called get all products. in an interface we don't implement anything, although starting with C#8 we can do basic implementations also in interfaces, but that is a whole other discussion point. Now we'll also have to add the using statement so that it knows from where it should take that product, and that's basically it. So we have defined in this interface right now this contract. An interface is nothing else than a contract. We'll basically have to implement a method that is called getAllProducts, and the way we implement it, or the implementation, is done by the service itself. I said, as the interface is just a contract, it just describes what a certain service is supposed to do or is obliged to do. So in this services folder, let's add a new class, and we'll call this class Cedar. It is a public one, and we say it needs to implement iCedar. Of course, we'll also have to add the using statement because it's in the interfaces folder, and here we can also, Visual Studio helps us to implement the interface, or it basically, well, creates us a method that in this case it throws a not implemented exception, because of course the implementation details are up to us, so the entire logic of implementing it. So let's go one step further. Now what we want to do here is simply have a list of products. Let's say, but the list of products, I think we want to have it as a property or private field in this class. So let's make it private. It shouldn't be read-only because we will add things to that, and it would be private list of product, and since it is a field, I use this naming convention to name the fields with underscore, and we can also say here it's a new list of product. That would basically mean that each time we create this, we create an instance of this class, we'll also have an empty list here. And then what we could do here is also create some new products, but yeah, let's make it like that. So var product1 equals new product, and we'll define the properties directly here. So it has an ID, I guess, and this ID should be 5. Or let's start with 1. What other properties do we have here on products? It's I think we have a name. Oh, we don't have a name. Let me go back to the product just for a second. We should have a name here, and it's also public. Okay, so we should have a name on product. But here, of course, it's comma. So we have a name, and here let's give it a name. IP camera. Let's also make it, I don't know, Logitech one, whatever. Then what we have is also a description, and in the description, I guess we would also have to write something down. And in description, we say does wonderful recordings or videos, which is what the camera is supposed to do. Then once again, comma. What do we have here is we have photo URL. I don't think we'll provide a photo URL, it doesn't make any sense, but what we can provide right now is a price, and this price should be, I don't know, let's make it 34.89, and it should be of course a decimal. And I think it really does make sense that we also create right now an instance of supplier, and that we and that we add that supplier. So the supplier will still be null, but I guess all the information that we need to play around with the products in an API we have already here. And what we can do here afterwards is we should add these products to the list. Products.add, and here we can have product 1. Okay, and then we should have at least 2 products. So yeah, let's create the second product, which would of course have the ID 2. It would be name. Let's make this a microphone. Okay, and here we will have also a description. So it makes some great voice recordings. We say what other thing? We also, this one should have a price, and the price should be, I don't know, 56.10. And that would be it for now. And then of course we can also add this one to the list of products. Add, and here we see product 2. Okay, product 2. Right now it should be. So what we will have to do right now is simply return products. So right now this seeder will create 2 products. It will put them in a list, and through this method that is exposed, which is get all products, it will then make sure that it makes available these 2 products at our disposal. So yeah, I think as a first implementation that's okay right now. Let's try to wire things up right now. And as said, the next step that we would need to do is register this service in the dependency injection container of ASP.NET Core. And we do this in the startup method in the startup class in this configure services method. So here is where we can add our services. And we can simply say services dot, and then we have add. And we can add it in different ways. Let's first add it like add scoped. Okay, and here we provide the interface and the service. Of course, we will also have to add the using statements for it, and then I guess it should work. Okay, okay, add scoped, it would what we can do here. Okay, we do this differently. Sorry, I think I got it wrong. It's add scoped, and then we say here seeder and seeder. Sorry for that. It's this way that we should do this. Okay, so this would add this service to the dependency injection container of ASP.NET Core. What this actually means is that it makes it available, for instance, anywhere in the application where we would need it. Right now we need it in this product controller. And let me take away this breakpoint. So right now, usually when we want to inject a dependency, we create a private field for it, and we will have private, let's make it read-only, because we don't want to update the list from here, or the field here, even though no, because we will probably also create products. So let's have here a private list of or no, here we need the seeder service. So, and in this case the service can be also read-only, because we don't change the service itself, and it's of type iSeeder, and we give it a name, and we simply define the service, or write the service that we need as an input parameter to this controller. And as long as ASP.NET Core will find an iSeeder service in the dependency injection container, it will inject it here in this constructor if we say that we want an iCedar cedar. And then in the constructor, of course, we assign the input property to the private field. So this is everything standard way. And right now what we can do is simply revisit these methods that we have so far, because right now we already have the list here in this cedar. So what we can do here is, for instance, simply say, okay, we want to return, and what we want to return is cedar get all products, because this get all products returns a list of products, so we can simply use it and return here in this statement. So right now I guess we can give it a try. So let's start the API again. It takes just a little bit. Now, if we go right now to API/product and we do a request, it should normally give us the list that was created, which is fairly cool. So basically right now we have a cedar that supplies us some product information, and we can get it right there in the application. Of course, if we go for product/5, it's still the old method, so it will still return a product with the ID of 5, because 5 is what we defined here in the URL in the endpoint. So yeah, let's close it. And right now what we can do is here in this get product by ID, what we can do is well, simply use the cedar, and we can say here var product, and here we can say equals cedar get all products. Here we can say first or default. This is a link exception, but it's get all products, sorry. This is a method, and then it would be this first or default, and here I can simply specify a predicate, and I would like to get the product. So I would like to get a product where the product dot dot ID equals to the ID that we get as an input parameter to this method. In this case, this should be a product right now, so what we can simply return it. And now we have in the cedar product with IDs 1 and 2, and here, so for instance, we can then make requests for 1 and 2. But another thing what we can do here is, for instance, if product is null, we can do either with is, or we can see if product equals null. So in this case we want to return not found. In any other case it will return okay and the product that we have there. So let's give it a try to see if this works. And yeah, we'll run the application again. So let's try this out. It will all be a get. So if we run a get with the ID of 1, I would expect it will return the product that it has the ID 1. If we want to make the request for the ID 2, it would simply return the product with the ID 2, which is expected. And if I put 5 here right now, we don't have a product in the list with the ID 5. and we can see that it responded to us with 404 not found. So they didn't found, or this product was not found, which is usually what APIs return when a certain resource is not found. So yeah, I get that. I think that this method is working well, or the API till now is working well as expected. So the next thing to do is, of course, we also want to be able to add products. So we'll have to create a controller action for this type of action that we want to perform. It would also return an iAction result. Let's name it create product. And now the idea is that what we will need here is we'll need a product as okay, something is not working well. Let's something just hit my space a lot of times. Okay, so we have this create product. What we need here is product, and we need the product that we want to create. And if you already worked with APIs and have just a little bit of experience, you probably know about DTOs. But for now, we won't implement a DTO right now. We'll come to this just a little bit later, and we'll see exactly what a DTO is, how it is used, and so on. But right now, let's simply expect that we get a product from the client, so from that entity that basically makes this request. So in this case, what we need to do here? Well, basically we get here a product in the request. We have, of course, to specify here also. We actually don't want to specify a route for this action, because I want it to be an the URL, so the endpoint should still be API/products. But what I want it to do here, this method will be triggered when we have an HTTP post. When we want to create resources, we usually use this HTTP post verb. So when we have an incoming request with the verb post, then this action will be triggered. Or better said, when we have an incoming request with the verb post and on the URL that we defined here, so API controller or products, then this action will be triggered. Now what we can do here is, for instance, we already have the product here, so what we can do here is say seeder. But here the seeder right now doesn't allow us to add some products. So yeah, we'll have to fix this. So we'll get back to the seeder. So first we'll need here a method that would return I don't know what should it, not void, because we should get some feedback at least. And let's make it return a bool, and it should return true if the product was added. It should return false if the product wasn't added due to any type of reasons. And here would be add product, and what we would need here is a product as the incoming parameter. Okay, of course we have to go over to the seeder, and we have to implement this method. If you go on the interface and use this light bulb and implement interface, it will already add the method for us. It's add product, which is okay. And then we can simply add the product to this products list. So it will be products dot add, and I would add the product, and afterwards I will return true. Okay, and then right now I have a way to add the product to the seeder. So if I go back to the products controller, I would say seeder.add product, and here we have product. Let's make it just a little bit fancy. Let's make it here var add result, so that I get the result, but I want the product as a name here, so not the type, but how this input is called. And here, for instance, I can say if I don't know, add result, or if add result is false, basically I negate this. In this case, I want to, well, return maybe, I don't know, what should we return? Bad result, bad request, sorry. And here in this bad request, we can also specify a message. And we say here that product wasn't added. Try again. But if the result is correct, then we would simply return. And here in APIs, according to the REST principles, whenever we want to return something, we return a specific status code, which is 201 created. So I can say here I return created, and here this created method basically first we need the URI, and then we need the value, and so we can specify here it would be HTTPS. It would be basically this URI here. I will then delete the parts that I don't need. So basically it needs to return the URI where the requester or the client can make a request to get basically the product that was just added. And here I can simply specify as a parameter that the product.id. So if it makes a call to this URI subsequently, the client should get then should basically hit this method here and get the product return that was added. Then we have to add the object that was added, so the product itself. And right now that should be okay. So yeah, let's go one step further and test this entire thing just a little bit. So first I want to go to ID2 because I want to get a product. The reason why I do it is, of course, I don't want to really handwrite all the entire JSON. So I will create basically a new request, and this time it will be post. It should be a post to API/product, but then it should also have a body. Sorry. It should have a body, and this body I can simply replace with what I have copied. Then in my case the ID would be 3. Then I guess, I don't know, name, what should be, let's create a Samsung Galaxy S10. I'm not even sure if this is really the last model, but whatever, it doesn't really matter. And just for information, I don't have an S10, so yeah, it's what would be the price for such a phone? I don't know, maybe $600 or something like that. Then supplier null and photo URL null, we leave this, or we can simply not specify that. So cancel. So right now we have this verb set to post. We have the URL to API products. We have a body. Let me put a breakpoint to make sure that we see everything that happens here. So let's then send the request. And the first thing that I notice is that it entered this controller action, which is expected. So this is exactly what I wanted to have here. And I see if I go on product, I can basically already see this information, but it's everything null. Okay, of course. Yeah, it's null because I have to close it and make a new thing here. We should use an attribute which is from body, because otherwise ASP.NET Core doesn't exactly know from where should it basically take that product. And if ASP.NET Core didn't know from where to take the real product, it basically created a product instance with all the default values for all the properties. So let's try again. So if you go on send, once again we see the breakpoint, and in this case, let's hope it's better. Yeah, in this case we see that we have a description, we have the ID, we have the name, we have the price and everything that we need. The only thing that are missing are the photo URL and the supplier, and this is of course because we didn't provide the photo URL and supplier. So those are right now, or those values are the default values for that specific types. So if we go further here, we see that what we'll do is we'll add this product to the list. Then we'll have the add result. We see that it is true. So normally it should simply skip this if statement. And of course it returns this created. So let's then continue. And let's see how the result looks like here. You see that it's 201 created. And if we go to the headers, we see that we have this location header, and basically the value that we put as incoming parameter, or that we put here on created, this URI, is basically populating the location header, and this is the header specific for APIs that return a created response or a 201 response. So this is according to the REST principles. These responses should include this location header. But of course, it's not only the header, it also returns in the body the product that was just created. So that the client exactly knows what product was created. So everything is very cool till now. So theoretically, I would expect right now that if we go for products /3, which would be the product that we add now, that I get this new product, but instead I get method not allowed. Of course, I have to change here to get, because I don't have a post for that. But I get a 404 not found. But how could that be? Because, well, I have added the product to the list, but it's still not there. And here is where the services comes in, or the way that we add services is very, very important. Because here in startup.cs, we added this service as scoped. What does this mean? This means that basically this service would be instantiated each time a new request comes in. So this service would be scoped for each incoming request. What would this mean? This means that if we think about it, so first we made a request to this create product. So it was one incoming request, or the first incoming request. So when the request came in, ASP.NET Core instantiated this service, this seeder service, which presents this list of two products, which is expected. But then what happened is that we subsequently made another request to get a specific product, and this means that it created a new instance of this seeder service. And the new instance of this seeder service would have the default two products that we hard code basically to this list. And if we want to change this in right now, we could say, instead of add scoped, we could say add singleton. And if we add a singleton, what this means is that it basically creates a new instance of the service once when the application is started, and then that instance remains basically in life until the application ends. So in this case, the service is not scoped to each request, but it's, let's say, scoped to the entire lifetime of the application. And this would change the behavior of our API fundamentally, because right now, since no matter how many requests we do, as long as the application is running, so as long as the console is open and we don't close it, then everything that we change to that list will still be visible. So let's try this out. First of all, let's create this product once again. So I go here in this list and I see where we made this post request, and let's do it again. And yeah, this product was created. And right now, if I go for the get request on the product with the ID 3, you see that now it returned it. It returned it because this service is right now singleton, so it doesn't really care about the requests. As long as the application is running, the service or the object of that seeder service is there, and every time we add something to that list, it will stay there and it will be visible until we finally close down the application. Closing down the application is basically we simply exit it, so it's closed. Right now, when we restart it, of course the list will contain the default 2 products once again, but this shouldn't be a very big issue right now. Okay, so if we go just a little bit further, I think for today we'll cover all the other or the important 2 other methods that we still need to implement, which will be the update, and then and then the delete, and I think we'll continue then some other time. So let's create a new controller action. It would be public I action result. Sorry. Result, and let's name it update product. Now, update actions usually, well, we have to specify some things here. So first of all, we would need to specify the HTTP verb, which for updates, according to the REST principles, is usually put. Now, this means that each time a request comes in that has the verb put, and it is on /API/product, it will go into this method. But actually, when we perform the update, what we want to do is, well, also define exactly the product that we want to update. And we can do this by specifying a custom route, I would say, which would be here, let's say, ID. So this would basically generate the exact same URL or the exact same endpoint like the get all product. But as long as we have different verbs, even if the route is the same, ASP.NET Core can decide or can find out which action should actually be executed. Because if a request would come in for /API/product/ID with a get verb, it will use this action. But if it will come with the verb put, it will use this action instead. And the only thing that we still need here is a product that we will take from the body, which will be the updated product. So the from body attribute. And here will be a product, and so that we know exactly that this is the updated one, we see updated, we name it updated product. Now, what we can do here right now is, well, to simply go ahead and, well, what we want to do, we just want to update a certain product that we have in a list, and, well, have it with a new value. Having this seeder, which is a very basic service, we can just expose in the seeder a method that would update the product. So this is similar with what we will have in repositories, only that of course for repositories it will be just a little bit more complicated. So what we can do here, we come to the interface and we see here it will also return a bool update product, and this method should take as an incoming parameter well, the product that needs to be updated, or the updated product. Or let's have first the ID of the product and then the updated product. So yeah, this is the interface method, so the contract. Of course, we'll have to come back here and implement that contract. So here we have this this method. So first of all, how we can very basically or in a very basic way implement this update? Well, it is simple. So first of all, we want to search for the product var product equals, and here it would be the seeder. Oh, it's actually a product called the field. Is the list of products, and here I would say first or default. I simply want to search for the first product, and of course I will use the ID as a criteria for my search. So I would use P in this lambda expression, like from product, and I want to find a product where the ID is equal to the ID that we got here. And then what we can do is simply if product not equals null. So if the product is not null, then what I would do is I will simply products.remove, and I will remove the product that I just found, and then I will add the updated product. I think that's the easiest way right now to implement it. I don't want to compare properties and update them. I think it doesn't make sense. Just remove the old one, just add the updated product, and that should do it. Okay, updated. I am missing a D. This is why I have this error. Okay, and after we have done this, we can return true, because we have to return false if the product is null. So if the product was not found, I can simply return false. And I think actually in my controller this time I will also use this result. So what can I do right now? I also have need the ID here as an incoming parameter, int ID. So what I can do right now is basically find a product and say no, I'll be using the seeder directly. So I will say seeder.update product, and I will pass in the ID and the updated product, and this will simply update my product. Now let's put this in a variable update result. So I will have a true or a false, and here depending on the outcome I can say if updated result. So if this is true, then I want to return okay, and I will return maybe just a message, in this case product was updated successfully. Well, in real APIs I might have I might return some codes that define some result and whatever. However, if the updated result is not true, so if it is false, then what I would like to do is to return a bad request, because something was bad there. And in this case I can simply say okay, couldn't update product, please try again. Okay, so this would be then the update. Let's also maybe implement the delete, and then we will be able to test both actions at the time. So I would have here a public action result, and this would be delete product. Okay, now in this case, what product would I want to delete? Well, first I would have to say that this action would be triggered if it comes with an HTTP delete verb. This is very, very important. And the route, so I should simply send it to the route that also contains the ID of that specific product. So I say here ID. And of course I can tell Asp.NET Core to give that ID back to me as an incoming parameter. So yeah, that was basically it. So right now I would have to use the seeder to delete a certain product that has a certain ID. And in this case, I have once again to go to the seeder interface. I would say bool delete product. Here I just need the ID of the product that I need to delete because I can find it based on that ID, and then delete it from the list. And in the implementation, if I go back, I would simply click on implement interface. So this added this delete method to this service. So what I can do here is simply var product equals products dot first or default. I want to look up that product, and of course I specify the condition in this lambda expression. So the condition is where the ID of the product, so PID equals ID. And here once again, if this product is null, so if product so if the product equals null, then what I would like to do is well, simply return false basically. But in any other case, what I want to do is products dot remove, and I want to remove the product that we previously found. And then I don't have to do anything else. I just have to return true, because in this case the operation was successful. So right now my seeder service should be able to delete a product. So let's go back to the products controller, and here in this delete method I would simply say var delete result equals, and here I would use the seeder delete product and pass in the ID of the product that I want to delete. Here I also can check based on the result. So if the result delete result is true, so I can simply say if delete result. In that case I would return okay, and in this okay I would say I was semicolon here. So in this okay I would then say what I would say here, product was deleted, which is kind of the expected result right now. If this delete result should be false, then this if statement won't so the execution won't answer this if statement. So I have to specify another what happens if it's not true. So in that case it will return a bad request because something happened, we don't know exactly what right now. But here I will say can't delete product, try again later, and that's basically it. So I guess now we can test this both this update and this delete method, or this delete product. And then this delete product I will have to also test it with an ID that is not valid. And let's see. So let's start the application. Okay, let's drink a little bit. Sorry. Yeah, the application is started. So what we will need, let's copy this to clipboard. So we need to make an HTTP put, and I want to delete this product with or to update the product with the ID 3. So this would be okay right now. So this URL, this endpoint would be okay. But in the body, I also have here this. But let's put also so that we have also the supplier right there. What do we want to update? Let's update the price and make it 700 instead of 600, and click send. It's sending. We see that we receive a bad request. Okay, let's check why did we receive a bad request. So let's put a breakpoint here and make the request one more time. Okay, so what we have here, we have an updated product, I guess, which has the new price, and we have the ID, which is 3. Okay, so something went wrong somewhere else. Let's see where. So let's go into this seeder. Again, here, let's see, we have the ID 3 and the updated product, which contains the new price. Okay, so let's see if we were able to find the product in the list. No, we were not able to find this product in the list. Okay, so we wanted to find the product because we haven't added it correctly. Okay, so of course, because we let's make continue here, because right now I know exactly what happened. So we closed the application. So this means that when we restarted it, the list was populated again with only two products. And in this case, we basically checked that that if the product is not found, then basically we will return a false from the service, and then the controller action will return a bad request. So we were able basically by doing this to right now test that this is working the way it is supposed to work. So in order to change this, let's first create this with 600. We will have to make a post request. So we will have to change it to a post, and it would have been need to be on this product. So let's make, and it was created, which is okay. And right now, if I want to update, so let's go on put, then I can use the ID 3, and then I can change this price from 600 to 700. And in this case, okay, I entered here the breakpoint. Let's take it out and let's continue. And we see that we received as a result 200 okay. And this means that right now, if I want to make a get, first of all, on this API products 3, it would only get me the product, and we see that it is updated. It's 700 right now instead of 600. But also, if I go to get product, so to get the entire list of products, we'll see that we'll have basically all 3 products right here, which is correct. Now, okay, let's try out the delete method. So this would mean that let's make an HTTP delete. I want to delete products and the product with the ID 3. Here we don't basically need the body, but it's really not important if we have it or not. So let's send the request. We received 200 okay. And the way we can check this is right now, make a get for the 3rd product, and we see that not found. So the product was not found. And if we make a get for the entire list of products, we'll see that we will have once again only 2, or no, we have 3 products in the list. That is strange actually. We have one with the ID 1, 2, 3. So some product was somehow duplicated right now. I think it's this one. Yeah, but the Samsung Galaxy is gone, so it's not here anymore. So it's totally gone. We don't have it. So it was deleted successfully, and we can see that we saw that also in the status code of the deleted, it is 200 okay. So product was deleted, which is basically what we waited for, or this was our expectations. This was expected. Okay, so I think that would be it for now. What we've done so far for this API, we have created a very basic domain model where we've created some classes like the products, like the customer, like the shopping cart, and so on. And then we went to the Twitch Eshop API, and we started to implement the API itself. We added a products controller for which we have right now implemented all the CRUD operations that we needed. And we have also created a seeder service, which right now is added as a singleton, as you can see in the startup, so that we can have some dummy products in our application in memory, basically, when each time we run the application, because we will add database layer. We will add a database layer only at a later time. So basically, that's the point at which we will stop right now. And I'm sure that we'll continue to work on this API in a stream the coming days, I would guess, where I think we'll go to add some validation, to try to understand what the DTOs are, because this is a very, very important part, as we don't really want to expose the IDs, for instance, when you create or put a product. When you change a product, you usually don't want to be able to change the ID, so you just don't need it here. So in this case, we will need the DTOs. We will then add some validation there, and we'll probably go over to the other models, and we'll create probably several other controllers, and then probably we'll think about implementing also a database layer. Thank you very much for watching. I hope it was useful for you, and I hope to see you back on my channel for the next live stream. So have a very nice day. Bye.